Hello everyone, and welcome back to another GIS lecture video. And in this lecture video, I want to take the concepts of fuzzy membership functions and fuzzy overlay that we've talked about up to this point in a theoretical context, and I want to apply them in the software to an actual data set, two actual data sets, so that you can see how these things work and mess with a couple of the parameters so you can see what I mean when I say we increase the amount that are given high fuzzy values, what that actually looks like, and then run through the different fuzzy overlay options to see how those play out in a real world data set. So what we've got is two data sets that we're going to worry about. We have the roads distance, which is distance to the roads in meters. And so you can see these black lines here. These are where the roads were. We get the brighter white means we're farther away from the roads. And then we have our elevation data layer. Again, darker colors means lower elevation. Brighter white colors means higher elevation. So in order to do any sort of fuzzy membership, if we search for fuzzy, there's two tools that we need to use, both of which are from the Spatial Analyst Tools package. The first is the fuzzy membership. So this is going to be where we apply those fuzzy membership functions to turn raw data values into fuzzy values. And so if we click this, you'll see that what we have are the input raster. So let's start with our roads first. Output raster, I'm just going to call this roads fuzzy default. Right. So membership type, right? This is the fuzzy membership functions that we talked about. And I'm going to go ahead and I'm going to do fuzzy membership large. Actually, I'll do regular large. All right. And so what I want to highlight here is for whatever we're theoretically talking about. Let's say we're talking about some sort of deer that would invariably like to be farther away from the road. So I picked large because I want to highlight larger values. And I want the fuzzy membership to get, or the fuzzy values to get higher the farther out we go, right? The farther away from the road we get, the higher the fuzzy value. So I'm going to choose large. Where do I want to set this? Well, I'm going to set this at 3 meters, right? So that S curve that we talked about, right? That midpoint, that 0.5 fuzzy membership or fuzzy value is going to happen at a distance from roads of 3 meters. I'm going to keep the spread defaulted because I want to show you what happens when we change the spread here in just a second. So if I click run, it takes just a second to run. Right, and what we've got here is you can see that in this case, right, higher values are shades of white, lower fuzzy values are shades of black, and you can see that we've got basically you can see the outlines of the roads as unsuitable, which is exactly what we wanted, and you can see that the suitability increases rather quickly in the sense that once you pass a certain threshold from the roads, it's almost immediately hitting that high suitability threshold or high fuzzy value. We can change that by increasing the or decreasing, I should say, right? If we decrease the spread, so I'm going to call this low spread. right? And so if I lower the spread to say 1, right? Again, if we think back to our stylistic example, what we're doing is we're making that slope, that transition of that S-curve more gradual, which means we're going to have more distance values in terms of road distance values being mapped to intermediary values of fuzzy values. So what that's going to look like is that these areas around the roads are going to become more blurred, right? We're going to have more intermediary values going from the roads out to the areas of high fuzzy values. So if we run that, right, our road center lines became more defined, right? But you can see that, especially if we zoom in here, right, that there's more of a gradient now, right? There's more intermediate values between the road center lines and then our areas of high fuzzy values out here, right? We've shrunk both extremes down, and we have more values now representing the middle. Okay, so I'm going to go with the low spread as our roads fuzzy layer. We now have to deal, I'm going to actually remove that. We now have to deal with elevation, right? And so for elevation, I'm going to do something similar, but instead of using large, I'm going to use MS large, right? And I'm going to call this default. Right, elevation, and I'm leaving everything default. So if I run this, right, again, we're going to have the mean of the data set. Everything below the mean is going to be 0, and then everything above the mean is going to be gradiated through to higher fuzzy values. And so you can see what happened here, right? All of these lower elevations are all basically 0. And you can see that where we get into the areas of high elevation, right, we start to gradiate into the higher fuzzy values. But let's say the mean, let's say that we've cut off too much. I'm going to decrease the mean multiplier by 0.5. So I'm going to push that inflection point back towards the minimum so that we get some more of these lower elevation areas included. And then I want to make the rate at which the fuzzy values change a little bit more gradual. So I'm going to increase the standard deviation multiplier. Right? I'm going to pull that value that represents 0.5. I'm going to pull that closer to the maximum. So I'm pulling the inflection point closer to the minimum and the 0.5 fuzzy value closer to the maximum. So what I'm going to get is a more gradual change in fuzzy values. So this white is going to be more shades of gray. And I didn't change the name, so we're going to keep our fuzzy default. Right, but you can see that we now have more shades of gray, and we've included more areas of lower elevation in our final fuzzy output. So we now have 2 layers that have been converted from raw data to fuzzy. And you'll notice that I did not have to use the same fuzzy membership function. I just had to use a fuzzy membership function so that the range of the 2 inputs are both in terms of fuzzy values. So we have fuzzy membership. Let's go ahead now and look at fuzzy overlay. So fuzzy overlay is going to allow us to combine our fuzzy layers. And this is that last video we talked about when we talked about the 5 fuzzy overlay options. So our first thing is going to be our inputs. So we're going to include elevation fuzzy default and roads fuzzy low spread. We're going to call this suitability. Right, and so for overlay type, right, we have our 5 options that we talked about. And I want to compare and, or, sum, and product. So I'm going to call suitability and I want to run. So again, what and is doing is and means both suitabilities matter. And since both suitabilities matter, the highest suitability you can have is the lowest suitability you have. So what suitability and ends up doing is giving you back the lowest suitability value of the 2 options. And so you can see what's happened here is that by and large, areas where our elevation was low, had low fuzzy values, that was retained. But you can see where some of the roads have cut up into these areas of higher elevation, where the road fuzzy values were lower, so they were returned. All right, so you can see some of these black lines up here are coming from the fact that we're keeping the lowest, and these were areas where we were close to roads. Now let's compare that to OR. So if we run OR, right, and again, remember that OR, the suitability OR, keeps the highest, right? Because in this case, we're saying, oh, as long as one of them is high, that's good enough for me. So we're going to get the highest fuzzy value for each of the pixels. Right? And you'll notice that what we've done here is we've actually washed most of the elevation out because the areas up here were relatively far away from roads. But you can see how in a couple of places, especially where we had moderate values for both, you can see the elevation along some of these roadways actually increased the fuzzy value. So again, suitability OR, right, especially down in here, right, where being farther away from a road meant more than being in low elevation, versus suitability AND, where in this case, right, being close to a road meant more than being in high elevation. So let's look at product versus sum. So again, with product, we're multiplying the 2 together. And so with product, you tend to end up with lower overall fuzzy values. And the more layers we include, the lower those fuzzy values are going to become. Right, and so you can see suitability product gives much the same overall picture as suitability AND, but you can see that it's actually even lower in terms of the maximum value, because again, when you multiply decimals or fractions, you get even smaller decimals and fractions. Right, and so product actually gives you a lower result than suitability AND, but it has the same general shape in terms of where suitability is higher and lower. And then finally, let's look at suitability sum. So again, with sum, you're weighing more so the higher suitability value or higher fuzzy values. And so you'll see that what we've done with suitability sum is it's much the same as suitability OR in terms of the overall appearance. Right? But again, just like with product versus and, right? Suitability sum is actually giving you higher suitability values than suitability or did. So again, just to recap, we use the fuzzy membership tool to access those different fuzzy membership functions to convert raw data to fuzzy values. And then we use fuzzy overlay to actually apply those different fuzzy overlay options. And in general, using and or product weights low fuzzy values highly, meaning your overall suitability will be lower. Using sum and or tend to weight larger fuzzy values, so your overall suitability will tend to be higher. And as always, if you have any questions, please reach out. Thank you.